In this question, we have a pen in which the rain is falling into. And we know that the rain is falling at the rate of 2.5 centimeter per hour, and the pen is 1 meter square. So this is really just like how much height it has per hour. And it's not really an SI unit. We have to deal with that later. So we know the rain is hitting at 8 meters per second. And we also know that the density of rain is 1 kilogram per meter cube. So that's all the information we had, and we are trying to find the force at the bottom of the pen. So firstly, that's a lot of information, but let's just try to write our most familiar equation about force, about what we're trying to find. We have force equals the change of momentum over the change of time, just the Newton's second law we know. And if we write change of momentum in terms of m times delta v over delta t, that's our most familiar equation. So we have the change of velocity, and the change of velocity we know is 8 meters per second because all the rain hits the pen 8 meters per second and it comes to stop. But what we need to know is what is m over delta t. So we have this density. So let's try to decompose m into density times volume. How do we find volume? Volume is height times area. But we have this height. We have we know the rain is falling at 2.5 centimeter per hour, and we know the area is 1 meter square. So that gives us, this is rho times 2.5 centimeter per hour. It's the rate. So it's pretty much height per time, and then we have area, and we have time. So that is great because now we know if we divide it by delta t, we are pretty much dividing everything by delta t, and we have this here. And this is mass over delta t. We can plug this into the original formula. So that gives us m times delta v over delta t equals, if we plug in this expression, we get rho of h over delta t. So h over delta t is again 2.5 centimeter per hour, and times area, which is 1 meter squared, and this whole thing times the change of velocity. So that is great. We have everything we need, and now we just need to plug in the numbers. Rho is 1 kilogram meters per second times 2.5 centimeter per hour. There is something we need to do about this because it's not in the same unit. But let's first write down everything. We have 1 meter squared, and we have 8 meters per second. And let's try to convert this into 0.025 meter over. It has over hour, but we want second because we have second everywhere, and that's the SI unit. So we will divide it by 3,600 because this is per hour. So if we want per second, it will be a much smaller number. So it's divided. If we substitute this expression here and we enter everything into the calculator, we will get 0.056 Newton, and that is the force at the bottom of the pen.